Hello, I'm John Bladen, and I'm going to be working with this project created by Amir Alavi. And I'm going to start by getting the URL to the GitHub repository. I'm going to go to a folder in Windows, get a terminal, and then git clone the repository. Go into the repository, open it with Visual Studio Code. It says reopening container, but before we do that, I'm going to change the dev container JSON file. I'm going to edit this line here so it passes all the devices through from the host operating system to the Docker container operating system. So from Windows to Linux basically. Although it's from the WSL2 system in Windows. I'm then going to build the container. Now I'm using an FT Foxtrot Tango 4232H for hotel interface board. I'm going to be using that for JTAG debugging. I want to pass that through from Windows to the Docker container. I'm going to do that by using PowerShell, and let me see if I've got one ready. Here we go. I've got USB IPD installed. If I do list, you can see that 3.4, so that's bus ID and device ID 3.4, has a vendor ID of 0403 and a product ID of 6011. So in my case it's 6011, which is the quad version. 6010 is the dual version, which is the 2323, I guess, version. So mine's quad version. I need to make some changes to work with the 6011. Anyway, it's already attached. If it wasn't, I would use the command USB IPD attach --WSL --bus ID 3-4. It's already attached. Then I'm going to go to Ubuntu, which I can create by going to Windows Terminal and saying, not that, this one here, and say Ubuntu. And I'm going to create a udev rule for that device. That's already done, but I'll show you what's been done. So I'm going to etc udev. I'm going to go to the rules folder, and I'm going to use nano to edit this file here. So this file is one I've created. It's 99-ftdi.rules. So ftdi is a type of interface, and in that I've got this line here. So subsystem is USB. The vendor ID is 0403. Product ID is 6011. The user group is plug dev. So only users who are a member of that group can use this device. And the mode is read write for all types of situation. So I'm going to, that's a file that I need to create, and then I would activate that by this command here. Yes, sudo udev adm control -- reload rules, reload dash rules. So enter my password and so trigger as well, yeah. So sudo udev adm trigger as well. If I now do ls dev tty capital U, we can see there's 4 devices. So that's for each of the ports on the FT3232H. And that's all we need to do. So this is working on WSL2. So this is beneath the Docker version of Linux. So we've got Windows, which is the main operating system. It has WSL2, which is where we've done this, created this rule, the udev rule. And now we're going to go to the Docker container. So that's created. We're going to create another terminal and see what we've got. So LSUSB tells us that we've got our device, 4232H, etc. So $IDF_path, capital letters. If we echo that, you can see that the path to ESP-IDF is given there. So we'll go there. I will navigate to the examples, getting started or get started, blink. Once we get there, we've got code dot to restart another instance of WS Code. I'm going to close the old one. So we're going to set up the environment for IDF development. So it's the path /export.sh. In fact, you put a dot at the start as well. So if we do IDF py and then menu config, make a bit more space. Example configuration, I'm going to change the 5 to a 2 for my board. I'm going to change the blink rate to 80. And then save that. I'm going to build the project. That's done. Now if I wanted to, I could flash this to the device. So the device, the ESP32 original sort, is already in bootloader mode. So that's the boot button press and reset. So this should work. It should be USB 2, because that's the one that's connected, the C port. We can see it's erasing, writing, looks promising. Okay, I don't have a reset connection to it, so it's not doing anything yet. But if I just reset it manually, it's now flashing fast, so that's all working. Now I'm going to leave it not in bootloader mode, because now I want to start OpenOCD debugging. So what we've done so far is we've configured the program, built it, and flashed it to the chip, and it's working. Now going to open another terminal. On the right hand side, you can see there's two terminals here. I'm going to navigate to the OpenOCD folder, so I can do that by going cd home folder dot ESPR expressive, and then tools. Press that a few times. OpenOCD. Share. And then scripts. So I'm pressing tab a few times to get the options. That's great. Now for my particular case, I need to change one of the interface configuration files. So I'm going to do that with Nano, because it's already installed. And it's going to be interface, FTDI folder. And then the one I want to change is called ESP, I think it's underscore, that's the one. And I'm going to delete, I'm just going to have a vendor ID and product ID for my particular chip, and that's it. Then we're ready to start OpenOCD. So it's OpenOCD-F and then the interface file, and then we want the board as well, so it's -F board, and we're working from the scripts folder, so we shouldn't need any extra paths. I don't know they do anyway. And then we want ESP vroom-32, because that's my board, and it's not found. So I think we need to install ESP IDF. Let's see if we can do it with $IDF path. Install. Let's try that. Not sure whether we need to do any more than that. I'm just going to try. Okay, so now we want to rerun export. So that's .idf path export .sh again. Maybe that'll work now. Yes, that's working. That's not only run without any errors, it's also still running. That's important. We want that still runs. And on the right hand side, we've got OpenOCD scripts and we've got bash. So if we go back to here, we should be able to start GDB. So if we go to the internet and let's get our command, which is this one here, and say ESP32, see how we use that. So we're not running it from Eclipse, we're running it from the command line, and it's yes, we've got an X and there's -Q to minimize startup output. So not sure that I got that wrong, but I'm just going to copy all of that and put it in here in case there's some small error, and I'm going to use all of that and see if that works. Yeah, so we've hit temporary breakpoint at main. So we do list, we can see our program. If we do n, we can start debugging it, and which means it's already flashed to the chip via JTAG, and I can tell you when the LED comes on. LED's on, LED's off. So that's JTAG debugging working, and that's working in a Linux operating system in a Docker container that's using WSL2 in Windows, including the rules that enable the FT4232H board to be used within the Docker container, and that's all working.